So good afternoon, everybody. Today we are going to see the next bit of the chapter number 2 from plastic engineering, that is rotational molding. And this rotational molding, the best application of rotational molding, I have shown you the beautiful videos. The overhead water tanks, large size water tanks, maybe 200 liter capacity to 10,000 liter capacity available in the market. You can see how large the products are. Rotational molding process is the process which produce largest components. Smallest components are prepared by injection molding and largest components are prepared by rotational molding. Remember this difference. I repeat once again. Smallest components are prepared by injection molding and largest components are prepared by rotational molding. Rotational molding process, one more important aspect is it produces hollow components. So it is not producing solid component. This is one of the important concept for rotational molding, that it always produces hollow components. And main principle of this process is that this process is called as high temperature and low pressure process. Many times the question was asked in the MCQ. So rotational molding is dash 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 dash. So 1, 2, 3, 4 option. High temperature, low pressure, low temperature, high pressure, low pressure, and low pressure, low temperature, low pressure. So any options, combinations may be given, and correct option will be high temperature and low pressure. So remember this. Now this process includes the rotation of the mold cavity itself. That's why name is rotational molding. In other processes, mold cavity fixed. In injection molding, in extrusion molding, in blow molding, in compression molding, only the flowing pattern of the parison or the whatever may be preform, it was different. Here, that is not the case. Your raw material is powder, granules, plastic granules, plastic powder. That is put into mold, and that mold is hollow, and that mold is made to rotate biaxially. Meaning, what is meaning of biaxial rotation? See this. Assume that this is a mold. Let us have assumption. Now, this mold is rotating at its axis. This is single. Okay. And now along with it, it is rotating around this finger. So this is single rotation, and along with it, it is rotating along with the own axis as well as central axis. At a time, 4, 8 molds are made to rotate around some axis, and then little less pressure, not very high speed. So RPM is very less. That's why it is low pressure process. But temperature of that mold is higher. Mold is heated by some means. What will happen? So if this is the mold, I will take this bottle, suppose. See, assume that this is a mold. So inside this mold, you are observing now little water. Assume that it is solid particle, solid plastic particles or granules. In this way, how it is lying, same way it will lie. So when it will be made rotated in this direction and again in this direction, what will happen? Whatever water inside it, it is touching all the inside surfaces. This mold is hot. Plastic becomes plasticized, reach into plasticized state, semi-solid state, and it will stick to the wall of mold. Once it will stick to the wall of mold, it remains there for some time. Mold is made, rotated for a particular period, and then it is stopped. Once you stop the rotation, see, there are two types of cooling. One is air cooling, another is water cooling. But remember, one more point of difference for rotational molding is that air cooling is preferred. Water cooling can be used, but it may cause shrinkage of your product. 99% air cooling is preferred for rotational molding. So some important points I am telling, because these are the points questions may be applicable to MCQ. Preferred air cooling to avoid. So it prefers air cooling to avoid the shrinkage. Now cooling is over, once cooling is over, what will happen? See, before cooling, let us see heating. I told that mold is heated. There are a number of controlling parameters. Which are the number of controlling parameters? Amount of plastic, heating temperature, heating time, rotational speed, and cooling time. I repeat once again, amount of plastic, then heating temperature, heating time, cooling time, and rotational speed. These are the important factors. Now, powder which you are putting into the mold, care must be taken that mold should not be overheated. If mold is overheated, there will be degradation of the powder and it will lose its properties. And your product may be of poor quality. If temperature of the mold is not optimum, if it is less, what will happen? Excuse me. If temperature is less, then there will not be proper plasticization. It will not be, powder will not reach into proper plasticized or semi-solid, and there may be bubble formation. Hence, mold temperature is maintained at constant and optimum temperature so that your product will give good quality after solidification or after cooling. Here, cooling is carried out, I told, in air cooling operation. Now, once cooling is over, and now I have to withdraw the product. You have seen that big tank metallic mold was there, and that water tank is removed just by pulling out. How easily it is pulled out? Why it didn't stick to the wall of mold? So it is interesting. And you have seen there is outer good surface finish at the outside. Good surface finish. How it is maintained? Because whatever inner part of the mold is there, that inner part is coated with lubrication. And you can, because lubrication, it is possible as it makes us possible to remove that part easily from the mold after cooling. So this is all about rotational molding. Let us see, I will dictate this part, but let us see the schematic diagram of rotational molding. Schematic diagram. This is axis 1, this is axis 2. Draw this figure. Write down principle of rotational molding. Principle of rotational molding. The rotational molding is high temperature and low pressure plastic forming process. Rotational molding is high temperature and low pressure plastic forming process. Full stop. Powder is poured into the closed split mold powder is poured into the closed split mold and rotated in biaxial direction. Rotated in biaxial direction to produce the hollow part. Full stop. Mold is rotated till molten plastic adhere to mold wall. Molten plastic adhere to mold wall and makes the thin layer. Full stop. Different speeds of rotation are used. Different speeds of rotation are used in order to avoid accumulation of molten powder. Accumulation of molten powder. Next line. If mold is heated for a long time, there will be degradation of the powder. If mold is heated for a long time, there is a degradation of powder. And if mold is heated for a short time, powder may not melt completely. Powder may not melt completely. Full stop. Air cooling is preferred than water cooling. Air cooling is preferred than water cooling to avoid shrinkage. To avoid shrinkage. Full stop. Different types of mold release agents. Different types of mold release agents are used in bracket semi-permanent coating or permanent coating. Semi-permanent coating or permanent coating. Next line. The important process parameters are first, amount of plastic, second, heating temperature, third, heating time, then rotational speed, and fifth one, rate of cooling. Thermoplastic material is the most preferable. Thermoplastic material is the most preferable material for rotational molding. It includes low density polyethylene, LDPE. Short form is LDPE, low density polyethylene. Then high density polyethylene, HDPE, high density polyethylene. Then polyvinyl chloride, PVC. Then polypropylene, PP. Now make star mark next line. Rotational molding is used for making number of components such as storage tanks, bins, containers, aeroplane parts, road divider cones. So you have seen on the roadside some cone shaped plastic components are kept and they may be used as a divider or variegating. So road divider cones. Then helmets and rowing boats. So you can just row it with the help of the rod. Rowing boats, BOATS. Advantages. Rotational molding allows complex mold split lines. Second, it allows molded threads and inserts. Third, wide range of surface finish textures are possible. Then low residual stresses. Then inexpensive tooling. Disadvantages. Rate of production is very slow. You can write. Rate of production is very low. Because it may take 1 hour almost for rotation and then cooling. Second, precision level is lower. precision level is lower. So friends, this is all about rotational molding. So in this chapter, what are the contents? Chapter is very contents are very less. Only molding processes are covered. So classification of molding process. Then we have studied injection molding process. Then after injection molding, we have studied extrusion molding process. After extrusion molding process, we have studied blow molding process. Blow molding is classified into three types. One is injection blow mold, second is extrusion blow mold, and third is stretch blow mold. Then these processes, and currently whatever rotational molding process we have studied, they are mainly used for thermoplastic. So which scrap is recyclable thermoplastic. Then two more processes we have studied. So before that, one more process we have studied, calendering for producing the sheets. Okay. Then two more processes are produced. Two more processes are used to produce the thermoset components, and these are compression molding process and transfer molding process. Transfer molding process is advantageous to compression molding. It is advancement of compression molding process. So in compression molding process, thick component products are produced and mold is heated there, plastic preform is kept, and then it is male female like jaw, and you are forcing, and material will flow in the gap between positive and negative side. Now it takes some more time for cooling. Okay, compression molding takes some more time for cooling, and here the rate of flow of molten plastic will be controlled by bottom screw arrangement. I repeat, rate of flow of this molten plastic is through or controlled by a bottom screw arrangement in the transfer molding process. Okay, so here separately heating is carried out in the upper chamber, and then once the plastic material is plasticized, then it is forced from the upper jaw, and then that cylinder is having one hole at the bottom side. Through that screw, material is taken into the closed cavity, and then your material will go inside. So it is little advancement over the compression molding process. So these processes we have covered in this topic. Now little discussion on MCQ will make. So how different types of MCQs are asked. Already booklet is provided to you, MCQ booklet. We have kept it on link. You can copy it. But let us have the discussion. How many of you are alert and how many of you are attended well? I will take name of any of the student and please give the answer. Okay. I will take anybody's name. I repeat once again. Now I am going to discuss few MCQs so that you can answer. I will take anybody's name. See, dash process is one of the most commonly process used for producing cap of the jar. So your plastic jar is there. So which molding process is commonly used for producing cap of the jar? Wasim Mulani, row number 36. Wasim Mulani, roll number 36. Are you there, Mr. Wasim? Wasim Mulani, roll number 36. See the casual approach. When teacher is calling, you should be 100% alert. You may not be with your mobile. Saurav Bhosle, roll number 11. Saurav Bhosle. Whether Saurav Bhosle is present? Roll number 11, Saurav Bhosle.
Yes, sir. Yes, sir.
Tell me, Saurav, which process is used for making the cap of the jar? Injection molding, rotational molding, compression molding, and blow molding. Cap of the jar. Big plastic jar is there. There is one cap. So that cap is made by which molding process? Injection molding.
Injection.
Huh?
Injection molding.
Correct. Injection molding. Correct answer. So now next question. Compression molding process is one of the dash molding process. See, compression molding process yesterday we have seen. It is high cost, low cost. Whether it is high cost or low cost compression molding. Ajinkya Jadhav, roll number 23. Compression molding process, whether it is high cost or low cost. Ajinkya Jadhav, roll number 23. See, how can we put their attendance? Roll number 23 and 36, I have to consider them absent. Roll number 45. Roll number 45. Mayur Pause.
Yes, sir.
Who is talking? Roll number
Yes, sir.
45. Tell me whether compression molding is low cost or high cost process. Whether it is costlier, whether tooling is costlier or it is cheap. Compression molding.
Sir, cheap.
How? Tooling is costlier. Compression molding we have studied yesterday. You pay attention, then you will understand the things. Next, transfer molding works on the principle of following process. Now, just before few minutes I told, this answer will be given by roll number 3. So Sonali Sawan. Roll number 3. Transfer molding works on the principle of injection molding, compression molding, rotational molding, blow molding.
Compression molding.
Correct. So transfer molding works on the principle of compression molding. Remember this. Okay. Then rotational molding is one of the dash process. Rotational molding is one of the dash process means high temperature, low pressure, high temperature, high pressure, low temperature, low pressure, and high temperature, high pressure. So which is the combination? So just few minutes before I told rotational molding process is high temperature and low pressure molding process. I repeat once again, rotational molding is high temperature and low pressure molding process. So such MCQ questions may be asked if exam will be objective type, and if exam will be subjective type, then these all processes may be asked for as a subjective question, maybe A, B sub questions for 5 or 6 marks. Okay, this is all about the process of 1 minute. This is all about the processing of plastic. And friends, so before we go to next part, let me discuss one important thing on this. I have shown some videos to you. You have seen many machines are so costlier. So injection machine, big plants are there. But for your kind information, if anybody want to become the entrepreneur, so there are many second-hand machines are available in the market. Only you require your contacts from the industry for whom you will work as a vendor. And there are thousands and thousands of products which main company don't want to invest their money and time. So they are giving it to vendors. So if you will become vendor of somebody and you will select any of small component in thousands and lakhs of capacity, then such small components may require very small die in injection molding. Once you invest that in die, get provided that you are getting order in 5 lakh and 10 lakh pieces, then you can start your own business as an entrepreneur with injection molding machines. As per my knowledge, some of the machines, our one of the alumni has started in here nearby Tempurnia VDC. Okay, then you have seen the rotational molding setup. Only small area is required, and 3-4 molds if you make. And already we have studied that rotational molding is not that much costlier. Only rotation and heating arrangement is provided. You can produce different products, overhead tanks and similar components. So that is all about this process. This chapter number 2 will give idea to you to become the entrepreneur. You are already in 8th semester. Okay, so start thinking whether to join any company or start your own business. This is one of the best way to start your own business. And nowadays banks are also providing the loans, and our central government has also launched the concept startups. So through all these concepts, if anybody want to show the interest and then anybody want to take the challenge, then this any of the molding process you can start as your own business. Okay, thank you very much. Just wait for 2 minutes. So now I'll take the attendance.